have on this slide. But I want to remind you that a parametric equation is often used to describe motion. That's not a function. We do this by writing the equations for x and t in terms of a third variable. That third variable is called the parameter, which is why we call them parametric equations. Okay? So x is a function of a variable, typically t. Y is a function of that same variable, like I said, typically t. What is the T in the Greek alphabet?
Tau. Tau.
The other one. Theta. Okay, so theta will also be used. I don't even think of tau. Theta will also be used typically when you have any sort of trig function involved. They like to use theta. Okay.
What should we write down?
The bottom part. Like, what is that squiggly line?
The parametric equation.
But doesn't that fail the horizontal test or whatever? Vertical line test?
It doesn't have to pass it. Not a function.
Oh, I should.
Sometimes it will be, sometimes it won't be. Okay? But the thing about parametric equations, their graphs have orientation. Okay? So what we are going to do when we graph these, we're going to give the graph, we're going to give the graph orientation by putting arrows.
Well, like, if it's not a function, then why are we saying x equals f of t and y equals t of t?
Because separately they probably are functions, but when you morph them together, they no longer make a function. Does that make sense?
Yeah.
Okay. So x is a function of a variable t, y is a function of that same variable. T is what we call the parameter. So we call this a set of parametric equations. Okay? And what I want to do today is go over graphing them as well as eliminating the parameter and then talk about one calculus concept. Okay? But you need to be able to understand what's happening graphically before we do all the calculus. Okay? Which we'll do tomorrow. So,
But you're having buffet, right?
That's true. I'm having buffet, so I'm going to miss the calculus.
you won't miss it because you'll watch the video later.
What's
Up.
buffet?
Up here,
Oh.
please write down this equation, or this set of parametric equations, and I give you a domain restriction. Okay? When we talk about the domain of a parametric equation, we talk about what t is restricted to. Okay, because that would be our input variable, right? So there's two ways we can get a graph from from a set of equations. One would be to create a table of values. Okay, and this is how both me and Miss Crunky start out our notes when we teach this to our pre-calculus, which you experienced 2 years ago. Okay. So what we can do is we can create a t, x, y chart where our t value goes from -1 to 4. Tedious, but all we have to do is plug t into the x equation, t into the y equation. So that's what I'm going to do. There's 6 numbers. Pod 4, plug in -1 and 0. Pod 3, plug in 1 and 2. Pod 4, or whatever you are, Pod 6, plug in 3 and 4. Or you just plug them all in there. Whatever.
Okay, so 3 squared is 9. Minus 1 is 7, 8.
That's not our job. We're over.
I don't think you were in middle school. We had a simple question called what is 8 plus 3, and I shouted out the answer 12.
Okay, what's our coordinate at negative 1?
0.
0, negative 2?
Yep.
At 0?
-1, 0.
At 1?
0, 2.
At 2?
I would have to say that was 3, 4.
At
Oh my
3?
God, that's 2, 3, 4.
8, 6.
Sorry.
And at 4?
15, 8.
Plus,
See a pattern.
what's the pattern?
I don't know.
And how can you see one?
Sideways per up.
Is there a pattern?
Well, let's look. Okay, we have 0, negative 2.
Well, it is indeed a squiggly line.
Negative 1, 0. 0, 2. 3, 4. Oh, man. 8, 6, 15, 8. So what we do is we connect these dots, but we have to also indicate the orientation. So we have to draw a couple arrows indicating that we started here and ended there. That's how the coordinates fell when we plugged in our t values sequentially.
So you could like just be lazy and express the other motion with the same two x and y like function and just do the arrow the other way. Like if you only do the same graph right there, but the motion's the other way, would you have to use two different x and y functions to do that?
Yes,
Or could you just do
because
that one and just-
Because you need to be able to plug in t values sequentially, like from smallest to biggest, right? To get that motion. So if you wanted it to go the other way, you would have to adjust your x and y. Yes.
Okay.
So you couldn't, like, if it was going the other way, just go from the bottom of the chart you created and go like 4 is 15, 8, and 3, 8, 6.
Here we go. I'm sure.
No, because that's backwards. You need to go from t is small to big.
Well, like if the direction was in the other way. Oh, so you, okay. I see it now.
Like when someone does a half of like this,
I just think it looks like a piece of a parabola.
Yeah, it looks like a y squared.
I mean, kind of is.
How are you Lee what?
We're not. Okay.
Huh?
Our second way is to do what we call eliminate the parameter and express the equation as one single equation in terms of x and y. So t is our parameter. If we eliminate the parameter, we basically squish the two equations together for one. Okay? Now, I don't necessarily have to give you this, but I guess I was nice. Okay? We automatically know that t is greater than or equal to 0. Why?
There's just radical t's there.
Okay, because of this radical t. I don't have to give you this, and I probably won't. So if you see some sort of radical or some sort of fraction that's going to affect the domain of your parametric equation, please think about that. Okay? So, in order to convert to a single equation, you need to solve for t and plug it back into the other one. Okay? Which t would you like to solve for?
T equals y.
Oh, y equals t. Okay, so here we know what t equals. We can hop over here. X equals the square root of y. Or we can write y equals x squared, where x is greater than or equal to 0. How do I know that x is greater than or equal to 0? Okay? This t restriction, when I plug 0 in for t, we get x as 0. So x also needs to be greater than or equal to 0 because we can't plug in any negative t's. Therefore, can't be negative.
This feels like something
Wait.
that I would very quickly forget. Like
So
my
can you
test.
not plug in like -1 for x on the far left one?
Well, that's a bold assumption.
If you, even though you get an answer, it's just
You won't get an answer.
But if you plug in -1 equals square root of y, you're gonna get y equals 1.
I understand. Okay, okay, I understand what you're saying. Yeah, we cannot because when we're up here, we can't plug in. There is nothing we can plug into t to get x to be negative.
But like
Do you understand what I'm saying? So when we talk about this graph right here, we are talking about y equals x squared, only the half of it, but we have to indicate the orientation. Okay? How did I know to draw my arrows that way?
Because it's going from smallest to largest to t's.
Okay, so when we plug in t as 0, we get 0, 0. When we plug in t as 1, we get 1, 1. So we know we have to follow that path from t as 0 to t as 1, t as 2, etc., etc., etc. Okay, I want to come over to this one, okay? I want you to take these two and eliminate the parameter for me.
Oh my gosh.
Eliminate the parameter.
I did it 7 minutes ago.
Okay.
That's not
What do you mean by eliminate the parameter?
Eliminate t. Write it as one equation without t.
Oh, okay. So t is 1 That would be, that is in fact a good idea.
You know what?
Okay, Marina, which one did you solve for t in?
I did.
Solve for x.
Okay, look up here. Don't use the x equation. You don't want a plus or minus
Why not?
in order to be able to plug in. That would be ridiculous. So y over 2 equals t. Therefore, x equals y over 2, the quantity squared, minus 1.
Same answer.
Okay? So we have a sideways parabola shifted back 1. That's a little bit wider. Okay? All right. Get out your calculator, yes.
Okay,
Oh, I tried to
So-
Zora.
in the equation, or wait, is it minus, oh, it's -1. So that would be why I got confused.
Yours is the same one too.
I don't like that.
There's parametric
Except for you're
mode.
missing
Yes, there's parametric polarity. I'm
You
guessing
have all
that's
of
sequential.
You have all of the rubber things. I see.
Yeah,
It's
sequence.
sequential.
Mm-hmm.
No, you have none of them. Give me one of yours.
What are you missing?
Oh,
Oh, one of your little,
dots.
Rubbers.
I'm missing all
Those
four of
sign
my
of zero
to
is
be
hard,
yours.
right?
I have 3 left.
okay. In your calculator, please go to mode. Mode. Radian would always,
Parametrics of mode?
What?
yeah.
Are you using that?
No.
Mode parametric, yes. Radian
Radiant
and
parametric?
parametric. You always want to be in radian mode in my class. With the exception of something that we do.
always, no matter what happens with this.
When you go to y equals, wonder what I did last year. Okay, when you go to y equals, you now have an x equals and a y equals. Okay, so go ahead and put in your radical t and what was it, t? Your x button will now be t because you are in parametric mode. When you're in, bless you, polar mode, this button is theta. When you're in sequence mode, this button is n. Okay? Now, watch up here. Watch. When you hit graph, it graphs. Oh, that was real quick. Okay? Does that look like a half of a parabola? No, go to window. Look at my window. My step is 7.5. That means every 7.5 it's plugging in a t. That does not make sense. What is your step?
0.13089969.
Probably pi divided by 12.
Nope. I divided by 24. Yeah.
Yeah.
And yours, I don't know why.
It's too high.
Okay, so now when I graph it, do you see how it graphs based on the orientation? Now, why does it stop right there? Because I restricted it from 0 to 2 pi. If I change this from 0 to 100, it'll graph and graph and graph and graph and graph.
Miss Coleman,
Yep.
mine's a blank screen of death.
That's always good.
It's in radian. Is that what it's supposed to look like?
Either zoomed out or zoomed in or something. Okay.
Okay, thanks.
Yeah, if I hit zoom 6, I'll go back to my little chunk.
Zoom 6 is the.
Okay, zoom 6 just sets you back to normal. Okay. I want you to be aware of how to change the window. Now let's go back to what was our second example? Was it t squared minus 1 and what, 2t?
Yep.
That's funny.
Now what? I only have half of the parabola. Why is that? Because this half of the parabola occurs when t is in the negative. So if I wanted to see that other portion, I would have to go to my window and make my t min to be something other than 0. And now I can see all of it.
It's kind of wobbly.
Zoom 6 gets you back to normal. Okay?
Why is it wobbly?
What is wobbly?
Just like bouncy. Can you see that?
Okay, because we're only plugging in values every 0.3, and so it's going to appear a little bit jagged. Okay, the smaller you make your t step, the more smooth your curve will be. Okay, but it'll take your calculator longer. Like if you put in 0.001 for t, you'll get that little like wheel spinny thing. Yeah. Okay. Okay, so we know how to work our calculator. All right. Write down this example. We are going to eliminate this parameter and then graph it.
So that's
Stop.
Okay? You are welcome to plug values in to make a graph, but we have a lot of knowledge about graphs. And so if we can eliminate the parameter and recognize what kind of graph it is and use our pre-calculus skills, it will be much more efficient. Okay? So yeah, we can plug in 0 and pi over 4 and pi over 2 and figure out what the heck this is. Or we can eliminate the parameter and go from there. Okay? What do you want to do? Solve for t?
sure.
Yes.
Let's go for it.
You want to solve for t. So you want to take x plus 1, divide it by 4, and that equals the cosine of t. So you would like me to take the inverse cosine?
Yes.
Oh, yeah.
Sure.
Should we construct a
Yes.
triangle?
It's arc sine. So
We get
it's
it,
so-
dude. You had your interview.
He said it went really
That
well
was
too.
rude.
That's
He
weird.
didn't even bring it up.
Also, I don't like people
Oh, no,
talking
you're
about
talking
it.
all day.
No. Y minus 2 over 5.
So we actually-
Yeah,
You
this is
said we actually
simple.
supposed to. I thought you were going
Oh.
Which one?
No.
Not that
Oh.
It takes 2 equations to make a parametric.
I thought you said we weren't actually doing. Yeah. You said no and.
Yeah, based on like how you're talking, I thought like we weren't gonna go
That was
that
one of
way.
those like.
But it
we
is
shouldn't
hard
do this.
cosine.
Yeah, we shouldn't do this. Wait, so are we doing it?
Yes.
She's writing it down.
So I was saying we want to graph it, but it would be inefficient to plug in random values to figure out what the heck this might look like.
No, like the arc cosine.
Oh yeah, we are not doing arc cosine.
Oh.
We are not doing arc cosine.
But that just sounds like fun.
You want sine of arc cosine equals y minus.
Could you do it?
Oh, wait, is this without?
Do you know what that
graphing
looks like?
calculator?
Yes,
It's like,
without a
I
graphing calculator.
Okay.
You would know what the sine of arc cosine of x plus 1 over 4 equals y minus 2 over 5 looks like?
What could the graphing calculator be?
You don't have one.
A little
I
heat
don't.
in it.
Not right now.
Oh, so this would be
Okay.
like a non-calculator. question.
Yes.
Okay.
But what relationship do we have with sine and cosine?
Lots.
Okay. Give me one. Give me one.
Sine squared plus cosine squared.
Sine 2 theta.
So x plus 1 squared over 16 plus y minus 2 squared over 25 would equal 1. And what do we have?
I would
An ellipse.
Wait, that makes sense. Oh wow,
I hate
this is crazy.
Yeah, I tried looking this
Actually
online
like
for the
ellipses.
book. That's
Yeah,
Okay, so where will I potentially go with this? Find places of vertical and horizontal tangency. We know there's 2 places of each of those on an ellipse. Okay, having that knowledge that this is an ellipse helps us think about whether our answer makes sense or not, right? Now, if we were to graph this, where's the center? -1, 2. Horizontally, how wide is it?
4.
4 on one side, 4 on the other side. Because this is 16, we would go 1, 2, 3, 4. And 1, 2, 3, 4.
Wait, what? Wait. Oh, and then the other one's 5.
Yes.
It's square root.
Like this is a squared and this is b squared, right? All you really need to know is that this gives you the horizontal distance from the center. This gives you the vertical distance from the center once you square root it, because we know those are a squared and b squared.
Oh, like it's H.
Yes. Okay, now we have a 50-50 shot of guessing the orientation correctly, but I would suggest doing this strategically. Okay, if we plug in t as 0, what coordinate would we be at?
Well, 3. 0.
2.
2.
Okay, right here. What about t equals pi over 2? -1, 7, right? So we know that our orientation counts. Okay. One little calculus thing before we go. Okay.
Find the derivative of the ellipse. Can you do that? There'd have to be at least 2 spots.
This is a smooth curve. This is not a smooth curve. well, I mean, that wouldn't be a smooth curve either, right? Because of this corner. Okay. Well, now we're in the parametric world, and things are a little bit different in the parametric world. Okay. But what we can say that if we have a parametric, that's not what I wanted. If we have a parametric set of equations, then we say that it is smooth if f prime and g prime are continuous and not simultaneously zero.
Wait, what now?
Okay, so this is what you need to write down. X and Y, it's called smooth if f prime and g prime are continuous and not simultaneously zero. Okay, now it does talk about an interval I on there. Interval I, like an interval, they named it I. Okay, so if we have an interval, we don't have to worry about the endpoints.
Okay, what is simultaneously? What is the zero?
Okay, so
Like if x equals
if
0
both
and
x prime and y prime are zero at the same time, that would be a place where the curve is not smooth.
Why? Isn't 0 like horizontal? Would that be 0? So it wouldn't just be a straight line for both?
Well, we're talking about parametric equations. And so,
So we're gonna have to say when it's not smooth.
yes.
So that would be
Okay.
or not.
Okay, kind of like when the derivative is undefined, right?
But it is defined as it's equal to 0.
Okay,
So,
but we haven't, what we're going to talk about tomorrow is how to find a parametric derivative, okay? And a parametric derivative involves both x prime and y prime together in an equation, okay?
So then it like differential equations or something.
Yeah. Now, one of them is going to help us with vertical tangents. One of them is going to help us with horizontal tangents, but when they're both zero, we have a corner. Does that make sense? Okay. Write these down. This is called a cycloid. I'll show you what it looks like.
I can already tell it's fun.
Sounds like a superhero.
It's really more like a supervillain.
It does sound more
Like a cyclone, but a cycloid.
Sounds like something that the Greeks
I
would
mean,
make
it's
now.
like cyclone-ish.
Sounds like something the Greeks would make
What if it's pronounced cycloid?
now. Like what?
Cyclone.
Okay. Nick, what's our derivative for x?
2 minus 2 cosine theta.
Okay. If we set this equal to 0,
Not good.
why? Because the cosine would equal 1?
No, I
Also,
wrote
it's
this.
smooth.
I wrote the wrong thing.
We haven't even looked at y prime.
But it's only if they're both not zero.
Or
Ah.
Well, I know, but I set this equal to 0. Now I'm solving for
Oh, so,
Wait, so
if
if it
y
equals
if you
one-
said y equal to 0 and then it's 1. then
what?
it's not zero.
Well, just you're getting ahead of yourself. Okay? Let's just set this equal to 0. When I solve for theta, I get cosine of theta equals 1. When does the cosine of theta equal 1?
At 0.
0 and 2 pi and 4 pi and, right? Okay, I'm going to write it like this for now. I know that we can write it differently. Okay, now, if we find y prime, Richard, what is y prime?
It's it'd be 2 sine.
Just 2 sine theta? The derivative of cosine is a negative sign, so they can't. Okay, so when we set this equal to 0, I'm essentially asking when is the sine equal to 0. Well, when does that happen? When is the sign equal to 0? 0, pi,
Oh,
2
no.
pi, 3 pi, 4 pi.
Wait, but they don't have the exact same answer.
Okay, so Caleb, where are they 0 at the same time?
At 0, and 4 pi, or 2 pi.
Okay, so we are not smooth at theta equals 2 pi n, right? 0, 2 pi, 4 pi. Because our y derivative is 0 at pi and 3 pi and 5 pi, etc. What do you think that means?
That means
It is smooth, but more specifically, what else would be happening?
Is this the piecewise smooth?
Okay. So this is what the graph looks like.
Burns.
Okay, so it's piecewise smooth, like in between 0 and 2 pi, and in between 2 pi and 4 pi. Okay? But it's not smooth at 2 pi n. At pi, 3 pi, 5 pi, etc.,
It is 0.
y prime is 0.
Not max. Not max.
Yeah,
What max?
We have horizontal.
horizontal.
Yeah.
So, why does this matter?
What was the question?
What's going on right
What are
now?
you trying to find?
We were trying to show where it was not smooth.
So it's not smooth at the like.
Yes.
Okay.
At these corners.
At the bird's head.
Yes.
At the corners. Okay.
Okay.
Okay. And since y, so tomorrow we're going to talk about dy dt versus dx dt. dy dt is 0 at all of these places I underlined in blue, which is where we have horizontal tangents. We'll get more into calculus tomorrow. Okay? Deep breath. Okay. Cool. I know it's deta dt. All right.